Hey, what's up, guys? This is Chung. So, I want to talk about today's daily challenge problem, number 754, reach a number. So this is a very interesting, I would call it like a math or greedy problem. So you're given you're standing at a position 0 on an infinite line, a number line here, and there's a target position, and on each move, you can either go left or go right. And the distance on each of the move is the same as the steps, the number of steps. So which means that at the first move, the range you can move is 1, right? And on the second move, the range you can move is 2. Basically, on the first move, you can do a either plus or minus 1, and the second one you can either do a plus or minus 2, and so on and so forth, right? And then it asks you to return the minimum number of steps required to reach the destination. And there are some examples, right? And cool. So, and there's a range here or the constraints. So the target will be a non-zero integer in the range of, see, though the range is pretty big, like 10 to the power of 9. I mean, if this range is small, like maybe only within a few hundreds, then probably we can use a BFS search because this one is like it seems like a BFS problem, but since we have like this kind of huge of the number range here, we cannot just use the BFS search because that would definitely TLE. So that's why we need to use a greedy solution concept to solve this problem. For greedy, I think one of the observations we need to make is it's like this. So we can do this 1, 2, 3, 4, 5 until n, right? And actually the problem is that we need to put like uh the different two one of the two either a plus or minus signs on each of the numbers here so that the final result will be equals to target, right? So that's that, and we need to figure out how many numbers we need, and the numbers are always increasing, like increasing by 1. Mm, so the observations we need to make here is like this. So let's say we are okay. So first thing is that if the target is like negative numbers, like negative 10 here, we can always convert this one to a positive 10 because it doesn't really matter, right? We can either go back, go to left or right. So the negative can always be converted to the positive because the left and right they are symmetric, right? So let's say we have a 10 here, right? And so the greedy approach is like this. We keep going to the right. We're trying to reach the 10 until we have bypassed this location. So if you're following this patterns here, so the numbers we're having is like the first one is 1, second one is 3, and then 6, right? And then 10, 15, 21, right? And then 28, 36, and so on and so forth. So so let's say the numbers, I mean it's 10. Okay, so if it's 10, obviously it's gonna be 4, right? So let's say for example we have the target is 11 somewhere here. Okay, so let's say the target is 11, and so once we have reached 15, we know, okay, we have the total number is already greater than 11. So here the difference is what? The difference is 4, right? Or you can call it the delta. 15 minus 11 is 4. So the first observation is this. As long as as long as the delta is in even numbers, then we can always flip some of the numbers from plus to minus to get the final to get this 11 the target within k at this like n move here. So why is that? Because so first thing, every time when we flip the sign here, the difference is always like an even number. That's the first one, right? And second one is that and we can always find a subset from 1 to the current numbers that the total will be the delta minor divided by 2. So in this case, it's what is delta is 4. So 4 divided by 2 will be 2. Right, so which means that we can find like numbers, either the one number or subset of numbers from the uh, previous numbers that we can flip that numbers to a negative number to get the delta. So in this case, we just need to flip this number 2 from plus 2 to minus 2 so that we can get the delta is 4. Okay. And I think the proof is also kind of straightforward because since the delta, since the delta divided by 2, you know, will always be smaller than the total number from 1 to the current numbers here, right? So we have 1 plus 2 plus 3 plus 4 plus 5, I think. So the delta divided by 2 will always be smaller, will not be greater than this total here. And since the total numbers consisting of each of the numbers from 1 to the current 5, that's why we can always find a subset of the numbers that can be equal to this delta divided by 2. Yeah. So I think that's the first observations. I mean, as long as I think that's the most important observation here. So as long as our current, I mean the current total, right, minus subtract the target, it's even numbers, and then we can assert, we can assume, we can say that we can always switch some of the previously signed there sign number of the sign of numbers to make the current totals to become the target, right? And then the question is that we just need to find the first total who has the delta is even number after bypassing our target. So yeah, so that's going to be our solution here. I mean, the proof is a little bit hard, but the code is kind of short. So like I said, first let's convert this target to its like positive values. Then we have the answer, right? So the answer is the steps, right? And then we have a position equals to 0. And so first thing we find, we increase, right? We keep moving to the target until we have passed the target. Okay, so this is the first step, right? So while pass is smaller than the target. Okay, and then we just do let's do like the answer plus one, right? And then we do a pause answer. Mm. Actually, we can do this, right? I mean, we can do a while the pause is smaller than target, or what? Or the pause minus target is divided by two is even, right? So if this thing is like this one, we always we increase these things, right? And then we can just return the answer here. Yeah, okay, let me try to run this one. If this one works, I will try to explain this one here. Yeah, so this one works. I mean, but I know so this one is a little bit confusing, right? Basically, I'm combining the two steps into one while loop. Maybe I should split them into two here. So what I'm doing here, so so first I will keep moving to the target until we have passed the target, right? And then and the second while loop is basically we're checking if the delta, right? If the delta is like is even or not. So if it's not even, we just need to keep moving until we find the first position who has the delta is the even number. Then we know, okay, that's gonna be that will be the answer. So that's why we have this one and position plus answer, right? Find the first that has delta has even delta, right? Yeah. So this is what I'm doing here. But so here, even though I have a while loop here, and it's not that hard to see it, so will at least at most needs two more steps here because let's say we have these numbers here, right? Uh, sorry, that's let's say we have this one, and then we have a 10, 15, 21, 28, 36, 36, and let's say for example we have 27. Right, we have 27 as a target, and the delta after first while loop here is 28. Okay, and the 28 minus 27 equals to 1. So the delta is an odd number, so which means that we cannot uh, get the 27 at this position, which means that we have to keep going to to 36. Right. So, but from 36 minus 27, the delta is 9, right? So it's still an even odd number. That's why we have to keep going to the next one. But the next one, it has to be an even delta because, so here we're adding like what? We're adding 8, right? But the next one is going to be the 9. So since here is an even number, we're increasing an even number, and the next one we're increasing an odd number. So at most two moves, right? Two more moves will get the a even delta here. And I'm just using a while loop to make this code a little bit shorter, right? Yeah, so that's why I was like trying to I can just combine those two conditions into one while loop, right? So and then we can this will also work. Yeah, I think pretty much everything for this problem. I mean the code is extremely it's very short, right? But the the proof is a little bit trivial, and the greedy approach is also kind of a little bit tricky, right? So just to recap, right? And the most important observations we need to make for this problem is that, we need to find the first position that can give us the uneven delta, and that position will be our answer because with the even delta, we can always make this current position to the target by flipping some of the signs, right, of the previously numbers. And as long as you can figure out that one, then the only thing left is just to find that's the first position that can give us the even delta. And then we have the answer. Cool. And yeah, I'll just stop here and thank you for you guys to watch this video and stay tuned. See you guys soon. Bye bye.